Hello students and a very warm welcome. Today we're going to start a very interesting chapter in your chemistry syllabus, metals and nonmetals. Now before we even open the textbook, I want you to just look around you right now. You might see an iron gate or maybe some shiny aluminum utensils in the kitchen. You definitely see copper wires somewhere around. But think about other things too, like a piece of coal or the oxygen we all breathe. All these things, they feel so different, they look so different, don't they? Well, that's exactly what we are going to explore today.
Okay, let's start with a little puzzle. I'm sure you've all seen a cooking pan at home. The part that actually cooks the food, that's always made of some metal, right? But the handle, the part you hold, that's usually made of plastic or wood. Why do you think that is? Just keep that question in the back of your mind. By the time we finish this lesson, you'll know the answer perfectly. So here's our plan for today. First, we'll start by just observing the world. Then, we'll dive deep into the properties of metals. After that, we'll look at nonmetals to see how different they are. We'll also look at some very important rule breakers. These are exceptions that love to show up in exams. Then, we'll do a quick summary, and finally, we'll get ready for our next lesson on chemical properties. Ready? Let's begin. Right, so first things first. Everything you see around you, the chair you're sitting on, the air you're breathing, all of it is matter. And all matter is made up of some very basic, pure substances that we call elements. Now, to understand our world, scientists had to find a way to organize or classify all these different elements. And the simplest, most fundamental way they did this was by dividing them into two very big groups, or families, the metals and the nonmetals. This whole classification is based on their properties. Today we're going to focus only on their physical properties. That means how they look, how they feel, and how they behave on the outside. So let's start with the first group. What exactly makes a metal a metal? What are those special characteristics that most metals share? Let's find out. One by one. The very first property is called luster. You know when you see a piece of gold jewelry or a brand new steel spoon, it has that beautiful shine, right? That shiny surface is what we call metallic luster. It's the natural shine that all metals have in their pure state. Even if you take a piece of iron that looks dull, if you scrub it with sandpaper, you will see that shiny surface hiding underneath. Next up, we have hardness. Just imagine trying to cut through a thick iron rod with a simple knife. It's not going to work, is it? That's because metals are generally very hard. Of course, this hardness can be different for different metals, like aluminum is a bit softer than iron, but as a general rule, we say metals are hard. Now, for a very, very important property. It's called malleability. Just picture a blacksmith. He takes a block of hot iron and he hits it with a hammer. Does the iron shatter into tiny pieces? No. Instead, it flattens out, it spreads. He can beat it into a thin sheet. This amazing property, the ability to be beaten into thin sheets without breaking, is what we call malleability.
And you see malleability all around you. Did you know that gold and silver are the most malleable metals of all? That's why they can be made into such thin foils. You've all used aluminum foil to pack your lunch, right? That's malleability. And in India, we often see those super thin silver foils on top of sweets like Kaju Katli. That is also possible only because silver is so malleable.
Now, very similar to malleability, we have another property called ductility. This is the ability of metals to be stretched or drawn out into very thin wires. Just think about the electrical wiring in your home. Inside the plastic cover, you will find thin wires of copper. How did they make those wires? By using this property of ductility. And to understand just how ductile some metals are, look at this fact. Gold is the most ductile metal. It is so ductile that from just 1 single gram of gold, that's about the weight of a small paper clip, we can draw a wire that is 2 kilometers long. Can you believe that? 2 kilometers from such a tiny amount. It's an incredible property. Okay. So we know metals are malleable and ductile. That explains how we can make cooking pans and wires. But it doesn't explain why we use metal for them. What is it about metal that makes it perfect for cooking food and for carrying electricity? Let's imagine a simple experiment in our minds. We take a metal wire and clamp it to a stand. At the other end, the free end, we stick a small pin using a bit of wax. Now we take a candle and start heating the wire near the clamp, far away from the pin. What do you think happens? After a little while, the wax at the far end melts, and the pin drops down. How? The heat traveled all the way through the metal. This shows metals are good conductors of heat. And this is why our cooking pans are made of metal, so they can transfer heat to our food efficiently.
So, metals conduct heat, but what about electricity? Okay, picture another simple circuit. We have a battery, a small bulb, and a wire with a gap in it. The bulb is off. Now, what happens if we place a piece of metal, like an iron nail, in that gap? The circuit is complete, and the bulb lights up immediately. This proves that metals are also good conductors of electricity. And this is exactly why our electrical wires are made of copper or aluminium. That brings us back to our first question, remember? The plastic handle on the pan is there because plastic is a poor conductor, which keeps our hands safe.
All right, one last property. What happens when you drop a steel spoon on the floor? Or think about your school bell. When you strike it, it produces a long ringing sound, doesn't it? This property of producing a ringing sound when struck is called being sonorous. So we can say that metals are sonorous.
Okay, so now we have a very clear picture of what a metal is like. It's shiny, hard, malleable, ductile, a good conductor, and sonorous. Now let's meet the other family, the nonmetals. And the easiest way to understand them is to think of them as, well, the exact opposite of metals.
So let's compare. Metals are shiny, but nonmetals, like a piece of charcoal, are dull. Metals are hard, but nonmetals are usually quite soft. Now, if you take that piece of charcoal and hit it with a hammer, will it flatten? No. It will break into pieces. It's brittle, the opposite of malleable, and you definitely can't make wires from it, so it's not ductile. And very importantly, nonmetals are poor conductors or insulators of both heat and electricity. One more thing. While metals are almost always solid, nonmetals can be solids like carbon, a liquid like bromine, or even gases like the oxygen we breathe.
Now, listen very carefully. This next part is extremely important, especially for your exams. You see, in science, for every general rule, there are usually a few exceptions. These rule breakers are very interesting, and they often become questions in your exam papers. So let's pay close attention.
First, let's look at some metals that behave strangely. We said all metals are solid, right? Well, except for mercury. Mercury is the only metal that is a liquid at room temperature. We also said metals are hard. But look at the alkali metals like sodium and potassium. They are so incredibly soft that you can actually cut them with a simple knife. And here's another one. Metals have high melting points. But gallium and cesium have such low melting points, if you put them on your hand, your body heat will be enough to make them melt.
And the nonmetals have their own exceptions too. We said nonmetals are dull, with no luster. But there is iodine. Iodine is a nonmetal, but it has a beautiful, shiny, lustrous surface. The most important exception, though, is carbon. Carbon can exist in different forms, which we call allotropes. One form is graphite, the material inside your pencil. Even though it's a nonmetal, graphite is a good conductor of electricity. And another form of carbon is diamond. We said nonmetals are soft, but diamond is the hardest natural substance known on Earth. See? These exceptions are very important to remember.
Phew, we have covered quite a lot of information. So, before we wrap up, let's do a quick revision of all the key differences between metals and nonmetals.
Let's just go down this table together, quickly. Luster, metals are lustrous or shiny, nonmetals are non-lustrous or dull. Hardness, metals are generally hard, nonmetals are generally soft. Malleability, metals are malleable, nonmetals are brittle. Ductility, metals are ductile, nonmetals are not. Conductivity of heat and electricity, metals are good conductors, nonmetals are poor conductors. And finally, sonority, metals are sonorous, nonmetals are not. This table is a fantastic summary for you to remember everything.
Okay, so we now have a very good understanding of the physical properties. We know what metals and nonmetals are like on the outside. But the next logical question is, why are they like this? To answer that, we have to look deeper at their chemical properties.
And that leads us to our final thought for today. We've learned how metals and nonmetals look and feel. But the really big question is, why? Why are they so fundamentally different? Why does one give away electrons in a reaction while the other takes them? The answers to these questions are hidden in their chemical properties, and that is exactly what we will explore in our next lesson. Thank you, and see you then.